Well, today we are discussing the chapter Polynomial. So here, before starting the chapter or details about what are the different aspects or concepts are there in this chapter, we'd like to understand the definition of polynomial. If we see the Google definition of polynomial, poly means many, nomials means terms. That means it's an expression of more than two algebraic terms, especially the sum of several terms that contain different powers of the same variable. That means more than two. If it is one algebraic term, then it is monomial. If it is two algebraic terms, then it is binomial. And if it is more than two, three and above terms, algebraic terms, then it is polynomial. So the definition part, from the definition part, what we can understand, any expression like your 2x squared minus 3x plus 7, it's a algebraic expressions consisting of three terms. And similarly, say 9x to the power 5 plus 2x to the power 4 minus 3x to the power 3 plus x minus 7 is equal to 0. So it's again a polynomial. Now, this definition part is there. Now we'll come to what are the different. First of all, we'll try to understand the terms. That is, the first term is constant. What do you mean by constant? Constant means it's remain same, irrespective of any changes. Means a symbol having a fixed numerical value is called a constant. Suppose 9 minus 6, 4 by 7, square root of 2, pi, all these are constants. Means 9 in India, the number 9 in India, the number 9 in USA or in China or in Japan or anywhere in the world, 9 remains 9. It doesn't change. But if I say the temperature, say that now at the moment while I'm recording the video, the temperature in Mumbai, I'm recording it from Mumbai, the temperature is around 40 degrees. But the temperature in USA and also different parts of USA, temperature in Japan, temperature in China, or even in India also, in different parts of India, be it Northeast India or Kashmir part of India or Chennai part, southern part, the temperature changes with respect to certain changes. So that are variables. So first, the constant means it's remain same. Next term is coming variables. Variables means a symbol which may be assigned different numerical values is known as a variable. Just like C is equal to 2 pi r. This is your circumference in geometry. Circumference of the circle, the formula is written by 2 pi r. 2 is constant, pi is constant, but r, the radius of the circle, is not constant. Depending on the circle, the r, the value of r keeps on changing. Therefore, the C is equal to 2 pi r equation is not constant. The product of the three terms 2, pi, and r, the ultimate product changes depending on the value of r. That means the radius of the circle. If the circle is small, then small value of C. And if the radius is huge one, then the value of C will be another multiple of 2 pi. So variable means it keeps on changing depending on the given value changes. Constant term understood. Variable you understood. Now we will be combining the terms to make an algebraic expressions. Means a combination of constant and variables connected by some or all of the operations. What are the operations are there? Plus, minus, multiplication, and divisions. So if we combine the constant terms and the variable terms with respective of the mathematical operations, that is plus, minus, multiplication, and division, certain expressions will be there. That expressions is called algebraic expressions. Now, terms of an expression. The several parts of an algebraic expression separated by plus or minus operations are called the terms of the expressions. For example, 5x squared minus 9x plus 4. It's a combination of so many constant terms and a variable terms. What are the constant terms? 5, 9, and 4. What are the variable terms? X squared, x, and these two variable terms. And they are separated by plus or minus. So this becomes an algebraic expressions. Hope up to this it is clear to you. If so, I will proceed to the next part. Next part is zeros. Just a second. Zeros of a polynomial. What do you mean by zeros of a polynomial? First of all, the polynomial is clear. So polynomial, any algebraic expressions having constant and variable terms separated by the algebraic expressions, that is mathematical expressions, that is plus, minus, multiplication, and division. So in this case, suppose in this example, there is an algebraic expression x cubed plus 2x squared minus 5x minus 6. This is an algebraic expressions. Now we can denote this algebraic expressions by a term, say px. Px. Since it is an expression of x, algebraic expressions of x, so we denote it by px. If it is an algebraic expressions of y, then we can express it by py or ty or such fy, qy, and so on. Now, here, the algebraic expression is denoted by px. Now, and the variables in this case is x with different powers. That means x cubed, x squared, and 5 and x. So here the powers are third degree, x third degree, then x second degree, then x first degree, then x 0 degree. You will say, where is the x in 6? 6, x to the power 0 is a 0 degree. So here it becomes an expression of a variable of x with degree 3. Now here what we are trying to understand is the concept of zeros of a polynomial. Zeros of a polynomial means what are the different values of x which will make the value of this polynomial 0. In this case, they are asking for, you need to see p2 or p minus 1 or p minus 3 and p0. Are they the zeros of the polynomial px? Now, first of all, px is equal to x cubed plus 2x squared minus 5x minus 6. It's clear to you. It's a polynomial denominated by px. Now, depending on the different values of x, if we insert the value 2 to x, then px will become p2. If we insert the value -1 in x, then it will be denoted by p -1, and so on. Means if x we means put the value x as -3, then it will be denominated by p -3. If we put the value of x as 0, then it becomes p0. Now, what is the meaning of p2? First of all, px is x cubed plus 2x squared minus 5x minus 6. And p2 means wherever x is there, we will place the value of x as 2. So p2 becomes 2 cubed plus 2x squared minus 5 into 2 minus 6. Now, 2 cubed means 8. 8, then 2x squared means x squared is here 4. 4 into 2 is 8. So 8 plus 8. Then 5 into x means 5 into 2 is minus 10 and 6. So ultimately it becomes 8 plus 8 minus 6. Minus 10 minus 6 becomes 0. That means by putting the value of x is equal to 2, the polynomial becomes 0. So P2 means 2 is a 0 of the polynomial. Next is P minus 1. Here, wherever we will get x, we will put minus 1. So minus 1 cube means minus 1. Then 2 into minus 1 square. Minus 1 square is plus 1. So 2 into plus 1. So it becomes plus 2. Then minus 5x. So minus 5 into minus 1. So it becomes minus 5. And 6 remains 6. So ultimately, what we become? Minus 1 plus 2 plus 5 minus 6. Ultimately 0. So all put together becomes 0. That means P minus 1 is a 0 of the polynomial Px. Similarly, P minus 3. So wherever we will get x, we'll put minus 3. So x cube means minus 3 cube. So minus 27. 2 into minus 3 square means 3 square is 9. Minus 3 whole square is plus 9. So 18. Then minus 5x. So minus 5 into minus 3 becomes plus 15 and minus 6. So it becomes 0. So P minus 3 is also 0. That means minus 3 is also a 0 of the polynomial Px. And P0. Wherever you get the value of x, we'll put 0. So 0 cube is 0. 2 into 0 square is 0. Minus 5 into 0 is 0. So first two terms become 0. And ultimately, we are left with minus 6. So putting the value of x as 0, we are not getting the value of the expression as 0, but we are getting minus 6, which is not equal to 0. That means, what happens? That means 0 is not a 0 of the polynomial Px. Hope this up to this is clear. Similarly, in example 2, check whether minus 2 and 2 are the zeros of the polynomial x plus 2. So here the polynomial is having only 2 terms. So let us denote this polynomial by Px. Px is equal to x plus 2. Now, putting the value of x is minus 2, Px becomes minus 2 plus 2 is equal to 0. So, minus 2 is a 0 of the polynomial x plus 2. But if we put the value plus 2, what becomes Px? P2 becomes your 2 plus 2 as 4, which is not equal to 0. That means 2 is not a 0 of the polynomial x plus 2. Next, we will see what next terms are there. Now, A0 is called a constant term of the given polynomial, and A1, A2, A3, and AN are called the coefficients of the term x, x squared, x cubed, x to the power minus 1, x to the power n, and so on. That means here, suppose the coefficient of the term x to the power n is called, denoted by an. Coefficient of the term x to the power n minus 1 will be denominated. Coefficient means the constant term associated with the variable terms, expressions here. So x to the power n, its coefficient will be denoted by a n minus 1. Suppose there is a term x to the power 10. X to the power 10. In such a case, say x to the power 10, there is a term x to the power 10. Then what? There will be some coefficient. What will be called that coefficient which is associated with x to the power n? It will be denoted by a 10. Similarly, if there is a term x to the power, say 5, and its coefficient will be called a 5. Now, suppose there is an algebraic expression where the coefficient of x to the power 5 is 6. So it is 6x to the power 5. In such a case, 6 will be denoted by a 5, and so on. Now, what we'll get here? Suppose example fx, because I told you that polynomial can be denoted by px, fx, gx, hx. If it is y variables, then py, fy, gy. If it is a z, then pz, qz, fz, and so on. Now, suppose the polynomial fx here is 7x squared minus 4x plus 2. Next coming is the degree of the polynomial. What is the highest degree of an algebraic expressions? The variable of the algebraic expressions. Here the algebraic expression consists of x variable. And to find out the degree of x, what we will do, we will arrange the x terms in descending orders. Means higher values first, higher powers first, then the lower powers, and in descending orders, we will arrange. Here it is x to the power 2, then x to the power 1, then no x. No x means x to the power 0. After arranging, we will see what is the highest value of x, since it is a polynomial of x. So the highest degree in this case is 2. Therefore, the degree of the polynomial is 2. Now, suppose py. Here the expression is 2y to the power 5 minus 6y to the power 4 plus 8y to the power 2 minus 5 by 7. It's a polynomial. Now the degree. To arrive at the degree, we need to arrange the variable terms in descending orders. First y to the power 5, then y to the power 4, then y to the power 2, and so on. Here you will see y cube is missing. What it means? Y cube is missing means y cube, the coefficient of y cube is 0. The coefficient of y cube is 0. So what we can write here? We can write it here 2y to the power 5, then is coming minus 6y to the power 4 then plus 0 into y to the power 3, then is coming plus 8y square. So this is the second degree. Then y. Y is not available here. Y term is not available here. So it is 0 into y plus the constant term. Here it is not plus, it is minus 5 upon 7. Although if this type are there, you need not have to write the 0 terms, but for your understanding, y cube is not available here. That means the coefficient of y cube is 0 and the coefficient of y is 0. And thereafter, you are arranging it. What is the higher degree? Highest degree of the polynomial is 5. So this polynomial py, the degree is 5. Up to this is clear. Next, we will be discussing qz. Here, qz is equal to z to the power n minus 1. It's a polynomial. Here, qz is a polynomial with variable z. And the expression is z to the power 9, z to the power 9 minus 1. What it means? It means z to the power 9. What is the coefficient of z to the power 9? Is 1. Then plus 0 into z to the power 8. So it's 0. And plus 0 into z to the power, it's not 7, it is 0. 0 into z to the power 7 and so on. Ultimately, it becomes z to the power 9 minus 1. And what is the highest degree? The highest degree of the polynomial is 9. So qz, polynomial of z with degree 9. So here, what we discussed two terms. One is the coefficient. Any polynomial, here, this polynomial x to the power 4. What is the coefficient of x to the power 4? Is 1. And it is a4. We can denote it by a4. a4 is equal to 1. Then 2 minus 2x cubed. So a3 is your minus 2. Then x square. X square is not available, means 0 into x square. So a2 is 0. Then fx is 5x. So coefficient of x is 5. So it is a1. And a1, the value is 5 coefficient. And so on. So the coefficients and the constant terms are clear. Here in first example, fx is equal to 7x square minus 4x plus 3. Constant term is 3. In second case, minus 9. In third case, square root of 2. In fourth case, minus 5 by 7. And in fifth case, minus 1. All these are the constant terms. So constant terms and coefficients are clear to you. Next is standard form of polynomial. A polynomial in x expressed either in ascending powers of x or in descending power of x is said to be in standard form. Means, suppose there is a polynomial, we can write, say, fx is equal to say 3x minus 6x cubed plus 7 minus 2x square. First of all, is it an algebraic expression? Yes. What are the terms are there? 2x square is there, 6x cube is there, x is there, and 7 is there. They are combined together with plus, minus, and multiplications. So this is a polynomial. Now, the question is it in standard form? No. To be in standard form, we need to present the polynomial either in ascending orders or in descending orders. So if we write in descending orders, how we are going to write? Fx is equal to first the highest order. Highest order here it is x cube. So minus 6x cube. Then second is minus 2x square. So minus 2x square. Then is coming 3x. So plus 3x. Then the constant term. Constant term is 7. Is this equation and this polynomial and this polynomial, are they different? No. Both are same polynomial, but in the second case, we are writing the polynomial in descending orders. When we are writing in this order, this is become a standard form. If we write it in ascending orders, then what will be? First is 7, then is 3x, then is minus 2x square, then is minus 6x cube. So this here, the order means the powers are arranged in ascending order. First case, the powers are arranged in descending order. And in the original polynomial, the terms are not arranged. So what standard form of polynomial means same polynomial we need to arrange in ascending order or in descending order. In such a case, it is a standard form. Now we will come to some examples. I would like to complete the video within 25 to 30 minutes. Another 5 minutes will be there, whereby I will be completing this part of the video so that the video becomes a comparatively smaller one so that you can understand. And thereby, I will be making different parts to complete the chapter polynomial. Now here, fx is equal to x plus 1 by x. This term 1 by x means what? It can be written as x to the power minus 1. So x plus 1 by x means x plus x to the power minus 1. X to the power minus 1. So this is a polynomial. Now, here the power is 1 and here the power is minus 1. Is it written in ascending order or it is written in descending order? It is written in descending orders. First the power 1, then 0, where we have not mentioned it, then minus 1. So this is a polynomial with standard form. Next, x to the square root of x minus 3. Square root of x minus 3, square root of x minus 3 means x to the power 1 upon 2 minus 3. This is again a polynomial, mainly binomial, because two terms are there. One is x to the power 1 by 2, another one is a constant term. But here the orders are arranged in order. X to the power 1 by 2 and x to the power 0. So it's a polynomial written in standard form. So what are the different things we studied here? First of all, what is constant term, which remains same. Then variable term, which varies. Just like the formula circumference is equal to 2 pi r, c is equal to 2 pi r. Depending on the value of r, the value of c changes. So it's a variable. Next is algebraic expressions. What is algebraic expressions? A combination of constant terms and variables. दोनों का combination होगा connected by or by some or all operations, that is plus, minus, multiplication and divisions, is called an algebraic expressions. Next is what we understood, zero of the polynomial. Zero of the polynomial, before that one, we will express the polynomial by px, qx, fx, gx, hx, ty, qy, and so on. First of all, we will be representing the polynomial by this form. Now, if any value of x, here the variable is x, in some cases, variable may be y, and so on. So the values of x which make the ultimately the value of the polynomial as 0. In such a case, that particular value will be called as the 0 of the polynomial. Now you will ask, what's the importance of this 0? Importance means while solving an equation, we need the roots of a equation. The roots of an equation. That roots of an equation or the solutions of an equation or the zeros of a polynomial are same. Next, what we understood is the constant term and the coefficient. Constant term means the number, fixed number, not associated with the variable, is the constant term denoted by S0. Because S0 means here the variable power is 0. Next, coefficients of the other term. Here, coefficient of the nth term will be denoted by an. Coefficient of the 10th term will be denoted by a10. Coefficients of the 5th term will be denoted by a5. Coefficients of the second order of the variable x squared will be denoted by a2, and so on. Then is coming the degree of the polynomial. Degree of the polynomial means the highest degree of the variable available in a polynomial is called the degree of the polynomial. Next is standard form of the polynomial, means a polynomial which is expressed either in ascending order or in descending order is called your standard form. And this we have not discussed it yet. We'll be discussing this in our part 2. So we are closing our discussions here. We'll see in the next class. Thank you.